So, I am going to be talking about hacking my home's audio and video today. First, an introduction. So, I'm Matt Morrison. I'm a software consultant here at Source Allies, and I organize PIO as well. Been a web developer for about 20 years, in the Python and Agile ecosystem for about 15 years, husband for about 20 years, father for about 10 years, lifelong nerd. It's my life in a slide. Moving on. All right, here's the plan for today. I've got some hardware set up here. I'm basically going to walk through my learning process. We're going to go through some slides and kind of just walk you through the process that I went through while I learned to do whatever all this is. Then we'll do a little tour of the hardware. I have a webcam that I had planned on like showing close-ups of some of this stuff, but it doesn't really translate. I don't know, the focus is all messed up, so I have photos that might just suffice, so we'll see how it goes. Then I'll do a software tour, walk you through all the code, and then we'll do a live demo to see how this all works and what it does. All right. Here is the setup in my home. So imagine, if you can, a living room with a television in it. That's kind of what we're working with. Beneath that, again, if you can stretch your mind enough to imagine a basement beneath that living room, also another component. And then I have what's called a Smurf tube. It's like a blue plastic tube that's in the wall that allows me to feed cables from the TV in the living room down to the basement. And so I've got HDMI cables running through that to connect the two. So all the components and things are hidden away in the basement. So here's a photo. So I've got a TV here. I'll show you, there's one cable that you can see right there. And then down here you can also see this is a Nintendo Switch dock. And so that cable is coming from the Nintendo Switch dock. This picture here on the right is the opening of the Smurf tube that goes down to the basement. And there's two cables and a whole bunch of dust being fed through that. One of those is an HDMI cable that plugs into the back of the TV. The other one is from the Switch dock, and they both go down to the basement. Everybody good so far? Make sense? All right. 1 second here real quick. Audio's good. Sweet. All right, so here's the basement. So I have this little rack in the basement with a bunch of things. I've got a PlayStation 3, a PlayStation 4, an Apple TV, there's a Google TV, and then this thing right here that you can kind of see, the glowing light, that is the HDMI switch. That in here on the right, this bigger picture, this is the back of that switch. The red, this is a red HDMI cable. That's what's going up to the TV. Then we also have this green cable here and a power cable. So this switch here, that's what I brought with me today. And probably right about now is when my wife is realizing that the television's not working. and this is why. All right, so more hardware. So I've got the switch. I also have a Raspberry Pi here, which I'll show a picture of later, that's running Raspberry Pi OS. And then I have this super fancy USB to serial cable that is like a, I don't know, Frankenstein cable that I have a picture of here as well. All right, so getting into some specifics, here's the hardware that I bought and kind of why I bought it. So here's the switch. So this was basically had the functionality that I wanted. I wanted like really just hands off. I just wanted something to work where I could have multiple devices plugged into it and didn't want to have to think about it a whole lot. So if I have like the Apple TV turned on and I turn on the PlayStation 4, I just want it to automatically switch to the PlayStation 4. And if I turn the PlayStation 4 off, I want it to switch back to the Apple TV, which it does that perfectly. The main thing we're going to be talking about today are those edge cases where it doesn't, where maybe I have the Google TV on and the Apple TV on and the PlayStation on, and I turn off the PlayStation, and then it either doesn't do anything at all, or it doesn't go to the one that I wanted it to go to, and because it can't read my mind, and it doesn't know which one I might want to switch to next. And you might notice it does come with a remote, which basically solves that problem. However, it's an infrared remote, which only works line of sight, and since this is in the basement and my couch is upstairs, that doesn't really work. And then you might also notice that there's this little bubble on a stick, which that's actually a cable, and that's the infrared sensor. So in theory, I could have just run that infrared sensor up the Smurf tube and put it somewhere where I could use the infrared remote. But honestly, I just didn't really want to. I could have, but I wasn't a fan of the remote because it just had numbers on it, and it's not super intuitive. I didn't really want to do like next, 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 or to have to memorize or have a little cheat sheet of the, PlayStation 3 is 3, PlayStation 4 is 4. That's intuitive, but then Apple TV, there's not really an intuitive number that would be assigned to, so I just didn't want to mess with that. And plus, it gave me the opportunity to play around and learn something, hopefully. There's 2 different options, but we'll talk about that in a little bit. We'll continue on kind of looking at some of the hardware. So this is the Raspberry Pi that I've got. This is a Raspberry Pi 5, 8 gig, and I got this kit, so this is definitely overkill. It's got all this stuff which isn't really necessary, but I just thought it looked cool and I wanted this one, so I got this one. But yeah, I think Raspberry Pi 5s are fairly new, and I think you can get one for like $80, maybe less if you get the smaller memory ones. But this one's pretty nice. I like the little fan and the little case and everything. So this is the one I got. And then the final piece of hardware is this cable. So this has got USB, which my Raspberry Pi has, and then it has this RS-232 3-pin Phoenix serial jack. I don't know what port thing, whatever that is. The RS-232 3-pin, that's what I was looking for in USB, and this is what I found. $20 seems like a lot. It probably is, but it's what I found and it's what I got, and it worked. So all right, so on the software side, so that's the hardware that we're working with. On the software side, I'm going to be building a little Python web app. I'm going to use some HTML, CSS, and JavaScript to build hopefully a more intuitive interface than just some numbers, and then a systemd service to actually run the app on the Raspberry Pi. Okay, disclaimers. Number one, I know very little about hardware. I have a background in web development, and as I'll talk about a little bit later, when it gets down to like communicating over a specific wire, that's pretty foreign to me. So I barely know what I'm talking about. I figured out enough to make this work, but keep that in mind if you have questions. I'll do my best, but I'll probably be best at answering questions about my experience and less so answering technical questions about how this all works. The other piece is the software is like very, very proof of concept. It works. It's definitely like a first iteration. There's some sketchy stuff in there that I will point out. All right, so disclaimers aside, this was kind of my goal, was I wanted to have something I could pull up on my phone that was very simple and intuitive, and it just listed my devices, and it would allow me to see what was currently selected and allow me to change what was currently selected. So those kind of 3 features is what I'm going for. List all the components, highlight in some way, which in this case, I don't know how well it shows up on the screen, but the Google TV is highlighted. It's got a slightly lighter background than the other ones. And then allow changing just by tapping the one that you want. Okay, so I had some constraints. Because I had no idea if this was gonna work at all, if I'd be able to figure it out. So I didn't wanna spend a ton of time. I didn't wanna pull in a bunch of frameworks and have like a big complicated application or a bunch of dependencies. Ideally, what I was hoping for was to get one single file that I could just drop onto the Raspberry Pi and run it and have that be it. I didn't quite get there, but I got pretty close. So I want minimal dependencies, a minimal number of files, a very simple deployment process, and then I just wanted it to start. When the Raspberry Pi boots up, I just wanted the app to start. Which reminds me, I should make sure it's powered on. Okay, that'll be important later. Okay, any questions so far about anything? Because we're about to dive in. All right. Let's see if there's any questions in chat. Oh, looks like Joey's in there. Sweet. Okay. So this is the switch. I was calling it Test Smart, but I think it's TE Smart because it says to enjoy smart, I guess. TE Smart maybe is how it's pronounced. I don't know. But it's an 8x1 HDMI switch. So it's got 8 inputs, 1 output. So these are the technical details. So this switch comes with 2 manuals. The first one is kind of the typical one that you would expect with any like appliance, where it's got like, here's what all the buttons do, and here's how you turn it on, and here's how you plug it in, and here's the troubleshooting guide, and that's the one you typically throw in the trash. So I threw that one in the trash. The second one was just 2 pages, and it had 2 sections. The first page was the serial guide, and the second page was they call it the LAN guide, maybe. I don't know if I have a good, but on the front there's like an RJ45, like an Ethernet port there, and in the back it's got that RS-232 serial port. And so it had like a 1-page guide for each of those 2 things. And I decided to go with the serial port for a couple reasons. One was, partially just because I wanted to play with that, because I hadn't ever done that before. And the Ethernet one seemed like it would probably be not too difficult to figure out. Like it would probably be pretty familiar to me as someone with a web development background. Like I would be making like TCP type requests and getting responses, which seemed pretty familiar. But the main reason was that port is in the front, and I wanted the cables in the back because I didn't want to have to mess with having cables in the front and wrapping around. So mainly it was so I could play around with it because it's a new toy, and also so the cables would be in the back. So that was my primary motivation for going with the serial port option. Okay, getting back caught up. So reading through that 1-page document, it's got this information. So serial guide, or whatever it was called. It says baud rate 9600 BPS. No idea what that means, but it seems important, so I'll make a note of that. Stop bit is 1 bit, data length is 8 bits. Those sound like things I could guess what that means. Probably, I'm guessing it means that there's some kind of bit at the end of the communication saying that is the end. I'm guessing that's probably the 1 bit, the stop bit. Data length, 8 bits. I assume that means we're going to be passing data back and forth in 8-bit chunks. Okay, baud rate. I'm sure that'll come up, so I'll make a note of that, and we'll move on, and we'll see what happens next. And I did look up baud because I wasn't familiar. Here's what it means. I I mean, conceptually it makes sense. I still don't really need to know much about that because I can kind of defer to lower level libraries to take care of that for me. All right, so the next thing I come across is this. And here in the document, it refers to each HDMI port as PC1, PC2, up to 8. So this is good information. This is kind of what I'm looking for one of the 3 features that I care about. Looks pretty straightforward. It's kind of the same thing each time. The only thing that is really changing is this digit here, which happens to match exactly. PC1 is 1, PC2 is 2, and so on. So makes sense. Still don't really know what to do with this information yet, but I can imagine this is the string of data that I'm going to be passing to that somehow, and that's going to make it switch what it's doing, which it's good to know. File that away, carry on, we'll see what's next. Okay, the next thing, this is the second, and I guess final, because the 3 features I needed were list all the devices, which I'm just going to have a hard-coded list of here's my devices, be able to change it, be able to read it. So this is the third and final thing that I needed. And it's another very similar message, very close, slightly different. So this is 10 instead of 1. And this is 0 instead of some other digit. And this one has some feedback where it comes back with an 11 here instead of a 10, and XX, where XX indicates which port it is. The one thing, and I don't know if you picked up on this or not, but 0 is 1, 1 is 2, 2 is 3. So 0 based, pretty typical. However, on this side, it's not 0 based, which was so infuriating to me that there's no internal consistency. Maybe there's a reason. Maybe they had 2 different teams building this. I don't know, but I almost told my wife that we had to move because there was going to be a house fire or something, because that just, I couldn't wrap my head around how that could be. But it doesn't matter. It doesn't matter. It's fine. We'll just add 1 and make everything okay again. All right. Well, spoiler alert. We're not going to go there yet. Okay. So I've got all the information I need. I've got this baud thing. I've got these messages that I'm going to be passing to there. I've got this message that I'm going to be getting out. And at this point, I still don't know what to do with that information, because from my past experience as a web developer, I don't really have to care like what wire things go on. I can just like shout out into the cloud, hey, I need something from www.whatever. Somebody else decides what wires that goes through, whether it's TCP, IP, DNS, whatever. All that stuff is taken care of for me, and I get a response. And so I don't have to care what port, what wire. I don't have to care about any of that stuff. And so that kind of started me on a journey of like, I have all this information and I don't know what to do with it. And I have my constraint of I'm really trying to just use the Python standard library because I don't want to bring in any dependencies if I don't have to. And so I'm kind of Googling, what can I use? What's in the Python standard library? I've used like Socket, I know is like probably the lowest level like external communication thing I've used in the Python standard library, and I had no idea if that would work for this. I didn't end up using that. I don't know if that is even relevant or would work. I don't think so, but maybe. But overwhelmingly, the internet told me to use PySerial, and I couldn't find a standard library thing where PySerial wasn't shouting down any other answer. So I was like, all right, fine, I'll look into PySerial. So PySerial was the first Python package outside of the standard library that I pulled in to start looking at. So I start looking through the documentation of Pi Serial, and I find something that looks like this, which hopefully you can see that all right. And so Pi Serial allows you to create a serial object. You give it a device and a baud. Oh, I know that one. I've seen that before. Timeout, which seems like a good idea. You can write some bits, give it a byte string, and then you can read a size, which I've seen a size before in the documentation as well. So this seems like I know almost everything I need to know except for this device, again, because of the shouting to the cloud and not knowing like how do I refer to this wire that's plugged into this Raspberry Pi. I don't have any idea. So that at least gives me a more narrow thing to search for of like, okay, I at least know device. I need device. How do I find device? What is that? So I start looking, and again, Pi Serial kind of comes to the surface of like, this will tell you. So I find something that looks like this. So Pi Serial has this list ports module that has a COM ports function that will list ports, and running this on the Raspberry Pi gives me something like this, which is like exactly what I was looking for. It gives me this, which I've definitely seen things that look like that in the past. So feel like I've got all the information that I need. I'm assuming that's going to be the device. I've got the baud. I've got the message size. I've got the bits that I'm going to be sending and receiving. So I think everything is good. I've got all the information that I need. So pause there. We've kind of already gone through the hardware. Really quick, just to kind of talk through what I actually have set up here. So I've got the switch and the Raspberry Pi they're plugged in, powered on, they're connected to each other. I also have this TV here, which is plugged into the output of the switch. And then just to kind of have, for demonstration purposes, I've got, let's see, what do I have? This is so this is my MacBook, and it's just mirroring my display. And is it showing on the screen? Is it off? There we go, turn it back on. There we go. Okay, so this is mirroring my laptop, and this is plugged into 4, which I think it should be showing 4 on the front right there on the little display. And then the Raspberry Pi its HDMI output is plugged into port 1. That one? Yeah, port 1. So when we demonstrate, we'll have those two things, so it'll be more than just seeing the number change. We'll be able to see the actual displays of the Raspberry Pi OS and my MacBook up on the screen. Let me know if that turns off again, because I can't really see that. All right. Oh, and then the other piece here is I have this long series of dongles that are connecting my MacBook to the Raspberry Pi, so I can SSH to the Raspberry Pi. All right, now it's time for the software tour. Okay, so the first thing I want to do is run through these on the Raspberry Pi, just to see if it even works. So I'm going to SSH to the Raspberry Pi. Here we are. And I have a Python virtual env that already has Pi Serial installed, so I'm just going to activate that and go into Python REPL and blow that up a little bit. That's not a thing. We'll just do this. Now it's at the bottom. We'll do that. All right. Okay, so we're going to first see if that device name is correct. So we're gonna do this first, because again, I don't know what I'm talking about. I don't know if that USB 0 is the one that's I don't know if that's referring to a specific USB port or if it's like the first USB thing that was plugged in. I'm not really sure. I don't know that I plugged it into the same spot. So I'm just going to run this code again to see what happens. So I'm going to do from serial.tools import list ports, and for port in list ports ports print port, and it is still USB 0. So that's good to know. And then there's this other one. Probably a Raspberry Pi thing. I don't know. So that's good to know. I'm going to say device is that. We'll use that here in a second. So now let's do this one. So I'm going to create a serial and device, and the baud was 9600, and we'll set timeout. Oh, I need to import that. Import serial. We'll set timeout just to be a good citizen. And then we're gonna do, was it right? Yeah. Our object.write, and then we will give it a byte string. And if we go, let's do this one first. So right now, it's currently on 4, so we should be getting back 3 in that position. So we're going to send this message. So it's AB310E. X, A, X, B, X3, X10, X0, X, E. Okay, no error yet. And I'm going to do read 8, read size 8. And we got back 3. So seems successful. That's what we're expecting. So far so good. All right, let's try the next one, this one. So let's try to change it. Let's try to change it to 1 so that this monitor will switch to show the output from the Raspberry Pi. So this is AB311E, which is very similar. AB311E, and it will make a beep if this works. There it was. And then we're going to do our read again, because if you don't, it can get weird. And this also returned the current port, and it looks like it switched to the Raspberry Pi. So good proof of concept. We're able to prove that the documentation, the good documentation that came with the switch, was accurate, and that worked. The Pi serial seems like that worked. So far that seems like everything is going well for what we need. So now that we have that working, now we need to kind of build up the rest of the application around that to put some kind of interface in front of it to be able to use it from a phone or something. So let's jump into some code here. Okay, so I'm just going to zoom all the way down to the bottom, and hopefully this will fit. All right, so we're just going to walk through the interface. Let's go back to the screenshot that I had here. So this is kind of what we're going for. So I want to try to build this interface in the simplest possible way that I can, with no frameworks, no dependencies, just very, very simple. So what I've got here, this is my app.py. This was my goal, was this was going to be it. I didn't Again, didn't quite get there, but got close. So this is my HTML. It's just a Python string, nothing fancy about it. I do have a couple placeholders for some CSS and some JavaScript, and then a couple placeholders here in the class attribute of these buttons, which we'll talk more about those later. But I've got a grid with some buttons. Each button has an ID of the device. So I've got Google TV, Apple TV, and so on. So that is my HTML for the structure of my page. So far, there's no code here to actually like serve that, but we'll get to that in a minute. The next piece is some JavaScript. So we'll go through this here. So we've got a query selector of the grid class, which is this. And we're adding a click event listener. And when that grid is clicked, we're going to make a post request to this update URL. And we're going to pass some JSON in the body that has a selected key with a value of the ID of the HTML element that was clicked. And so again, those are these values here. So it'll be one of the devices. After that post request is kicked off, the next thing the JavaScript is going to do, it's going to grab all of the components, which are all these buttons, and it's going to iterate over all of them and say if the ID of that component that it's iterating over matches the element that was just clicked, it's going to add this current CSS class. If it's not, it's going to remove the current CSS class. And that's all that does. And here is a big chunk of CSS, and the current sets a background to white. By default, all buttons have a background of dark gray. The other CSS in here is just styling some buttons, sizes, setting some background images. This was where I broke my single file deploy, having these background images in there. I thought about doing like inline SVGs, but I was like, that's way more work than just having the images there. But so yeah, there's our CSS. So we got our HTML, we got our JavaScript, we got our CSS. That's the UI portion. So how are we going to actually like serve that up from this file? So that is the next piece. So initially, again, I'm trying to keep it to standard library stuff, not trying to pull in any external dependencies. So Python, in the standard library, there's a library called WSGI or WSGI ref, which allows you to run a web app. And so I was like, I'll use that. Spoiler alert, I didn't end up using that because it is definitely a reference for how it should work, not something you should actually run. And if you do run it, you can probably count on it failing at some point randomly, is what I found. Because yeah, I started with running it there, and I would like 2 days later try to pull up the app and it just was not responsive, and I would have to restart it. I'm not really sure why, but I did end up swapping it out for something else. But the nice thing is, since WSGI is a standard, the thing serving it is pretty swappable, so it's ended up being not a big deal. But anyway, at least for looking at the interface, we can still use WSGI ref to look at our app. So I'm using this. App is the name of the WSGI app that I've got. So let's take a look at that. So here it is. Here's my app, and as per the standard, it takes an environment and a start response function. And I'm checking a few conditions, otherwise I'm going to return a 404. So let's take a look at what those conditions are. So I'm grabbing the path and the request method, and first, if the path is just slash and the request method is get, I'm going to return whatever this page function returns. If the path starts with assets and ends with PNG, I'm going to return whatever this static function returns, and I'm also passing the path into that. And then we have this update, which you'll remember from our JavaScript down here. That's what we're doing a post request to. So if our path is update and our method is post, then I'm going to call this update function and return whatever it returns. And in addition, I'm also reading the WSGI input, which would be the body of our, oh, go away. This would be the body of our post request. Any questions about any of that so far? Okay, we're going to peel back one more layer and go down to look at what this page thing is actually doing. All right, so I'm going to comment this out for now and change it. So I'm just going to say current is 1, and we'll kind of skip past the get current input for now. So I'm also going to kind of gloss over these two. We'll come back to that. So on our page function, we're calling start response to say it's a 200. It's an HTML. Sure, fine. This is where we're using those constants that I defined down below. I'm doing HTML.format and then passing in my CSS constant, my JavaScript constant. So this is what's kind of stitching all those static strings together to make the page that is going to be served up. And then, yeah, we'll come back and we'll talk about these here in a second. So let's actually run this, and I'm going to disconnect from the Raspberry Pi here and just run this locally. So I'm just going to do python app.app. And then I'm going to pull up localhost 8000. And there you have it. Beautiful. Exactly like what I wanted. And our JavaScript should work. It's not actually going to do anything because it's not connected to the switch, but at least shows that the JavaScript works and it is selecting different things and it's changing the background color. So far so good. User interface check. Any questions about that? All right. Let's go back to the stuff that I glossed over. Here we go. And I'm going to stick this back so I don't forget later. All right. So the stuff I glossed over here is we've got this get current input, which we'll talk about in a minute. We can assume that's going to talk to the device and get us whatever is currently selected. Then here, we're using this ports constant dot get whatever current is. So let's take a look at this ports constant and see what that is. So it's just a list of what devices are plugged into which ports. Pretty straightforward. This is, for whatever reason, those were the ports that I had this stuff plugged into originally. And we'll have to keep in mind this one is the Raspberry Pi, and this is the MacBook. I'm not going to change that now because that's hard-coded in a bunch. Remember, pre-alpha, this is proof of concept only. So this is hard-coded in many different places. All right, so that selected, that is going to be one of those strings, basically, going from one of the integers to one of these strings. So the next thing that happens is we have this options thing, and this is a kind of long for the size of font I have here, but it's a dictionary comprehension where we have name and then a ternary thing here, and we're looping over the ports values, so the list of strings that are the values of that ports dictionary we were just looking at. And we're saying if the name that we're looping over is equal to the selected one, it's going to be current. Otherwise, it's going to be nothing. And this options is also getting splatted into our HTML. So we'll have a dictionary with a key of one of these and a value of either current or nothing. And if you remember down in our HTML, we have this. So those are the values that are getting splatted into that HTML dot format. And then you remember the current CSS class is what changes the background color to white. So that's how that initial load is going to grab the current state and highlight the appropriate device. Questions? Okay. We're going to skip the get current input right now, and we're going to look at this next method that we were calling the static. So this is what's actually hosting up the images for the icons of all the buttons. And this is the one that is definitely concerning. You shouldn't ever write this code. It takes in a path, and then it opens that file and then serves that back to the client. That is maybe the most textbook, don't ever do this web API that anyone could ever make. So I'm sure this could be exploited in a bunch of different ways that would not be good. So this is, again, pre-alpha. This is quick and dirty. I just needed images on the page. But yeah, that's what that's doing. It's just opening a file and serving it back to the client. Okay, and then the last URL, we basically had three. We had page, static, and update. So update, this is the final one. And remember, this is the one that we were grabbing the WSGI input and passing that in. And so here we're that stupid tooltip thing keeps coming up. We're parsing that as JSON and grabbing the selected key that we were passing in our JavaScript. And then we're passing that selected key into this update current input, and then just returning a 204 no content, because the front end already automatically updates what's selected as soon as you click. It doesn't wait for the response back from the server, so it just returns a 204. All right, so the last piece here is the get current input and the update current input. So those are the only two pieces we haven't looked at yet, but we kind of already did the proof of concept of those exact things earlier on the Raspberry Pi. Oh no, cancel. What did I do? All right, whatever that was, we're past it. Okay, so get current input. This should look very familiar. It's what we just did. I've got device and baud hard-coded up here as constants. The get current input, it's always the exact same each time. For some reason, the sleep seemed necessary. Honestly, don't remember why. Could be a lot of reasons, who knows. And then we're doing the read just like we were doing, grabbing that fourth bit and adding one, because we can't have nice things. So yeah, that's the get current input, and this is returning that integer that we're then translating with this dictionary here. On our update current input, very, very, very similar. Really, the only difference here is we have this string concatenation happening where we're getting passed in, remember, from the JavaScript, we're getting the string of like PS4, PS3, or whatever, Apple TV. So this is going to translate that from that string into the appropriate digit that needs to be included in that string. And then again, the mysterious sleep, and then the unfortunate +1. And we're not using this anywhere right now, but I figured just to be a good citizen to my future self, that makes sense. All right, so that is the entirety of the application. Any questions before we go to the next thing? All right. So we pretty much checked off our 3 features. We have our list of devices. We have our getting the current device. We have our updating current device. We have our constraints, minimal files. We ended up with, I don't know, what is 5 or 6 files maybe. Minimal dependencies. At this point, we just have the one dependency, PySerial. Simple deploy, we can still just SCP this file to the Raspberry Pi. Simple enough. The last thing that we haven't touched on yet is to make it start automatically. When the Raspberry Pi boots up, I want the app to start. So that is the last piece. And unfortunately, it's going to add another file. So that is where I used systemd. There's probably lots of different ways to do this, but this was the one that seemed the simplest. So really there's these 2 pieces are the important part, and we'll kind of walk through the process here, but I'm just dropping it in my home directory in something called app, and this is where I ended up installing Gunicorn because that seems to be pretty stable, and I've used that quite a bit in the past. So that is the second dependency. So I've got PySerial and Gunicorn ended up being my 2 total dependencies that I used, and that's already installed on the Raspberry Pi in my virtual env. And then, so Gunicorn again is respecting the WSGI spec, so I can just say it's in app.py, it's called app, and it will find it and run it. And then it's running it on port 8000. So the actual deployment process, and I've got this in a README. So to actually deploy this, like on a brand new, let's say, quick aside, quick story. I ran through this last night to make sure everything was all working. As I was unplugging and like putting all the wires in my backpack, something caught like on my watch, and the Raspberry Pi went flying across the room. And I was like, that sucks. But luckily it was fine. It didn't break. Apparently it's very durable. So if that were to have broken and I could have got a new Raspberry Pi, these would have been the steps that I would have had to do to redeploy my app to the new Raspberry Pi after getting the OS and everything set up. So I could basically just SCP app, which app is this directory that has my HDMI.service file that we looked at earlier. It's got our app, and it's got all our image files. And that's it, and the README, I guess, too. So SCP, that will copy that to the Raspberry Pi. Then I can SSH to the Raspberry Pi, and then I just have to copy the HDMI service file into the systemd folder, reload systemd, enable the service, and start the service. And that's it. To deploy a change, very similar process. Can SCP, if I just change the app, I can just SCP that file, and then SSH out there and restart the service. Any questions? If not, let's pull up the actual app that's running on the Raspberry Pi, port 8000. And again, this 192.168.0.2 is because I'm physically plugged into the Raspberry Pi. So here, it's on port 1, it should say 1, which is actually the Raspberry Pi. Port 4 was that, what was port 4 again? In here, the PS4, yeah, that makes sense, is the MacBook. So in theory, click that and switch to the MacBook. There we go. So yeah, now all you gotta do is hit a button and it switches the device. And since basically nothing is plugged in there, we just have the Nintendo Switch is going to switch to the Raspberry Pi, and the PS4 is going to switch to the MacBook. That is it. Yeah. So we hit our goals. We stayed within our constraints. All of the code, all of the manuals and documentation and slides and everything is in this GitHub repo that you should be able to access. I've also got my LinkedIn and Blue Sky up there if you're interested. Yeah, any questions? How do we do on time? All right, good.
Have you deployed it to the family yet?
I have,
Yeah.
and then I started preparing for this talk, and I yanked yanked the Raspberry Pi, and I actually got my daughter the other day. She has a little phone she's 9, so she has a phone that doesn't have any service, just Wi-Fi, and she's like, it's not. The app isn't opening. And I was like, yeah, that's because the Raspberry Pi is right here. It's not plugged in. Anything else? Yeah.
Does it do everything you want it to? Are there more features you'd like to add?
It does everything I want it to. There are some things, I don't know if there's features that I want to add, but there's definitely some I can demonstrate. Some quirky behavior that I generally can avoid. Yeah, this is running on the Raspberry Pi. Okay, so if I were to click on Google TV and then like reload the page, something weird happens, internal server error. And so I think the reason is because I don't think that serial communication, this is just a theory, I have no idea, but I don't think that serial communication works well in like parallel environments where if I've got the click from changing it and the refresh to fetch it, I think the refresh is going to get part of the response from the change, and the data gets kind of all messed up. I have no idea how to fix that. Maybe that's what I was trying to fix with that sleep in there. I think the sleep actually may have made it worse, but there's just some quirky behavior like that I've noticed where I just get kind of these intermittent errors, and I think it's just that kind of concurrency issue or something like that. So there's definitely some of that stuff that I want to make it more stable. And maybe in this type of environment, maybe there's always going to be that risk of like the parallel things are going to mess it up. But that's the main thing. There are a couple other features, but not super interesting, that you can like additional messages you can send to it. Like you can turn off that beep, which I don't really care. But I thought about having like a little admin panel where you can go in to just adjust like whatever those other messages are to be able to tweak those, but not a super high priority. But I think I would like to clean it up a little bit, maybe make it so the devices are a little bit less hard-coded and maybe more data-driven, so I could like go into the app and actually say like, rather than having to redeploy the app every time, have like a little, I don't know, SQLite database or something that has, this port 1 through 8 and here's the devices, and be able to, like if I'm in there like unplugging and plugging things in, I can just change it in the app itself. But just little things like that. Anything else?
Now that you've dived deep into the world of this, is there any other projects you're like, I'm going to put this to work over there?
Are there any other projects? Yeah, actually, well, I guess related to this, and maybe this kind of builds off of the other question of are there other features that I want to add to this. I did at one point have the idea of, so we've got like Google Assistant and Siri, Apple HomeKit, and so I thought what would be even more convenient than an app is just like a verbal switch to the, or turn on, switch to the PS4 or something like that. That is another thing that I kind of have rattling around in the back of my head. That would probably be related to this. That would be another area that I've never kind of delved into yet. But that might be the kind of the next kind of home hacking type thing that I mess with. Anybody have anything else? All right. Well, if not, thanks for coming. I'm going to check the stream here, see if there's any questions. Doesn't look like it. All right. Thanks, everybody. Thanks for coming.